In this video, we are going to continue with rules of differentiation, and we are going to continue with the constant multiple and addition or subtraction rule. You will find this on page 261 in the Namibian AS-Level Mathematics textbook, Y equals mx plus c to success. In the previous video, we introduced the rules and we were looking at a few basic examples. In this video, we are going to focus on more advanced examples. Let's first look at the examples. Find the derivatives of each of the following with respect to x. So if I give you this one, okay, see that a is also a constant. Okay, so let's start with number a. Now, remember from the previous videos that we don't want the variable, the function, in the denominator. So we must always bring it first to the numerator. We didn't differentiate in this step. We were just getting the function ready to differentiate. So move the variable from the denominator to the numerator. So as soon as I move it up, then that exponent, that index becomes -3. Okay, that is all right. Now I'm going to differentiate. Now because there's a y, we can go for dy by dx. So there is the constant. I want to highlight it even for you. This is the constant. Okay, so this is the constant. So if I'm going to look at this, I'm going to now just differentiate this part. So it's -3, there's the -3, bring that down, the index, and then basically just subtract 1. So -3 minus 1 will be -4. That is the constant, so I differentiate just the x, and actually it's just going to give you 1, and that's why it still stay a. And now I can multiply this, and now I just want to show you, because there, it's almost like it cancel out, so it go in 1, and it go in 3, and that's why, and then a negative times a negative will be a positive, and that's why you get 4/3, and then bring it from the top to the bottom, x to the power 4 plus a, and that will be your answer. Okay, now if I look at the next one, there is the next function. Now remember, we also don't like a root, and we also don't want the variable in the denominator. So bring it up. But now I want to show you this step, and I'm even going to make it a bit bigger because I did it in the textbook. Now, do you see in this step that you are sitting with an x there and an x there? So if I bring it up, then it's going to be x to the power -1/2. That is coming from the root there. Now, I can first simplify this by saying, what do I do with the exponents? If the bases are the same, I add it up. So 1 minus 1/2, and what will that be? 1/2. So basically, if I'm going to differentiate this part, and can I just show you there? This is actually now becoming this. Okay, so you don't have to do it here. Do it on the side and just bring the simplified one back. Take note, we did not differentiate yet. As soon as we make that dash, we are differentiating in this step. Okay, so in this step, I'm going to differentiate now. So basically, there's the constant. I'm just leaving it there, and I first differentiate that. So it's 5x to the power 4. There's the constant. Differentiate, so it's 1/2. And then don't forget, can I show you? That was 1/2, what I always say, minus 2/2 or 1, and that's why it's -1/2. And that's why I can bring it down again. Remember, it's actually standing in the numerator, and if I bring it down, it will be 1/x to the power 1/2, and then I'm taking it back to the root. And I'm just saying -4 times 1/2, so, or 4/1, it goes in 1, 2, and that's where the 2 comes from. 3 times 5 is 15. I can simplify in this last step. Okay, and if I look at this one, this is very important. Divide each numerator term by the denominator. So get it ready before you differentiate. So just break it up like I showed you there. Take the denominator, it's for this top term as well as for this one. And then I'm getting x in this one, And then don't forget to bring that up. So it is x to the power of -1. And now I differentiate. So if I differentiate this, it's just 1 minus 1 is 0. So it's just going to become 1. -3, this is -1 minus 1, it's -2. And then basically I can just multiply. And in the final step, I can make this exponent positive again by bringing it down. Okay. I want you to stop the video and I want you to do the following numbers. Let's just move it up a little bit. Okay, I will move it down as soon as I start with the video again. Okay, I want you to do number 1A and C, and number 2A and B. You can continue the video as soon as you are finished, but very important, first try to do it on your own because you will follow the video better after you did it. Okay, let's just make it smaller again and I'm going to start doing it for you. Okay, let's start with number A. Find the derivative of each of the following with respect to x. Okay, so it's y, and that's why they give in this notation. So it's very important that you concentrate on the notation and write it correctly. Okay, so in this case, this is number 1a. So I prefer to write first the function down. So this is going to be 5 x to the power of 4 2 over x minus, so I first write it as it stands there in the textbook. Okay, now I'm going to get it ready to differentiate. Remember, I'm not indicating I'm differentiating because I'm not differentiating. I'm just getting, I want to bring that one up, I want to bring that one also up. So I'm going to get 5 x to the power 4 plus 2 x to the power -1 minus x to the power -2. And that's what I'm getting in that step. Now I'm ready to differentiate. So I'm going to get dy over dx. Okay, so this is going to, okay, I'm just going to, later on I will multiply, but for now, let's just write the 5 and differentiate the function. So I'm going to get 4x, 4 minus 3, 4 minus 1, that will be 3, I'm thinking of the answer, plus 2, and in this case it's going to be -1, and x -1 will be -2, minus, okay, and now I'm going to, this is just a 1, and this is going to be -2, and x, and -2 minus 1, it's going to be -3. Okay. And that is going to give me now an answer of 20 x to the power 3 minus 2. Okay, I'm going to, I can already bring it down, but just for the beginning videos, I'm going to not do it in the next step. This is going to be positive 2, and it's going to be x to the power of -3. And in the final step, I'm just going to simplify to make it positive. No, sorry. Okay, and I'm just bringing that 2 down. Sorry, I was just not thinking at that moment. It's very important that you think while you're busy doing this stuff. Okay. And there, and that will be my final answer. Okay, but again, I can leave it in that form, or I can simplify and make all. Usually we make the index all positive. Let's do number C. And I prefer giving everyone a space so that you see nicely. Okay, so let's do number C. Again, what is the function? Write it down. It's always good. Otherwise, it's easy to make a mistake. So in this case, it's 4. And if it's a little bit small there, but it's x to the power -8. Plus, and again, see your variable on top, but also see the variable at the bottom. Okay, so we have to simplify a little bit first there. So before we differentiate, let's get it ready. I want to show you. Just do it here on the side. So if I'm going to, that is the x. And, okay, I'm going to do it in a little bit more steps. So that is a half. Are you with me? I'm taking it out of the root. Now I'm bringing it up. So it's x multiplied, and if I bring it up, it's going to be -1/2. And now I'm simplifying it. So remember, if the bases are the same and it's multiplied, I add it, so it's 1 plus -1/2. So it's actually just going to be x to the power of 1/2. Okay, so it's the best, do it if you want there on the side to help you. And if you can see it, it's excellent. Okay, directly, then do it directly. Okay, and now I'm going to differentiate, and I must indicate it, dy by dx. Okay, and now in this one, I'm going to do it directly. So I just take this index and I multiply it with the constant. So I'm going to get -32, and I subtract 1 from the index, and that is going to be -9. Okay, and then it's going to be 1/2, and it's going to be x. And don't forget, and I can show you again here, if you're going to say it's 1/2 minus 1, so it's going to be x to the power -1/2. Do you see how I got that? With the white I indicate. And now I can simplify and say, okay, it's going to be -32. Now bring that one down to make it positive. Usually we make it positive. And this is going to be 1/2. And okay, actually I can, if I bring it down, it's going to be x to the power 1/2, but I can already put it back into root notation. And it's going to be like that. And that will be my final answer. Okay, let's look at the next one. I have to move it up a little bit so that we can see. Okay, number 2. Let's start there. Okay, let's make a yellow one. That's nice. Okay, so there's my function. See, that's now fx. So it's another notation, and we're just going to run with this notation now. Get used to the different notations and try your best to write it accurately, because it's almost like a language. You're talking while you are busy writing. So you are indicating when are you differentiating and when are you just simplifying. So in the first step, basically, I'm just going to simplify. That's what I'm going to do in the first step. So I'm going to take this denominator and I'm going to put it on every numerator. I'm doing it. I'm not indicating that I differentiate. So it's 3x over 4x squared plus 2x squared over 4x squared minus 4x to the power of 4 over 4x squared. Okay, so now I'm going to go and I'm going to see what happens after I did that. Okay, so let's just quickly see. So in this case, I'm getting 3 over x. Now, I'm already, just because I'm already with a few examples, I just want to, I can now just write it like this. It's 3 over 4. Now the x is going to be at the bottom, but I want it on top. So you can actually just say 1 minus 2, and then it's negative 1. Okay, then it's actually ready to differentiate. So in this case, it's 2 over 4. So I can already simplify it to a half. Do you see? And that basically just cancel. The force is also there, and it's going to be just x to the power of 2. And now I'm ready to differentiate. So now I'm indicating that I differentiate by that dash. So if I take this and I multiply, I'm going to get negative 3/4. And if I subtract 1, then it's negative 1 minus another 1, and that's negative 2. A constant is just becoming 0, so it's just falling away. So, and then this one, it's 2x, 2 minus 1, and it's just 1. And I can simplify that to my final step. Don't forget your negative. Oh, sorry. Just want to make it a little bit longer. Put it at the, take it down. Remember, if it stands on its own, it's actually on top. So I'm taking it down, and I'm just writing my minus 2x. And that's my final answer. Okay, let's do the last one. Okay, and the last one that we are going to do, and that's number B. And that's going to be fx is equal to square root x plus 7. I just have to look nicely at this last one to make sure I'm writing. So it's x 7, and it's a cube root. Okay, do you see that? Minus 1 over, oh, it's quite a lot of roots. But this is a 5th root, and here's a 2. Okay, again, get it ready. Don't differentiate yet, just get it ready. Take it out of the root, always out of the root. And then 7x, this one on top, this one at the bottom. Okay, now in this case, and I don't want to put so many steps, but just remember that it was actually, let's first take it out. So it was, okay, let's just put a 1 there, and it is x, 2 on top, 5. Do you see? And if I then take it up, it's going to give me that minus x, and because I'm taking it up, it was positive, so it's minus 2 over 5. Do you see that? Okay, and now I'm starting to differentiate, and I indicate it with my dash. Okay, so if I differentiate, I get a half x, and now don't forget, so it's a half minus 1, so a half minus 2 over 2, so that's to the power negative a half. Do you see that? Okay, this one, okay, I'm going to, in this case, put a little bit of extra step. So just to show you, I'm bringing that 7 over 3 down. Do you see? And then I'm saying, now I'm going to put this extra step also. 7 over 3 minus 3 over 3. We will now simplify it in the next step. And then this one, there's the negative. I'm going to put it also due to the negative. So it's negative 2 over 5. Let me just write it correct. It's my space, that's my problem there. Let's just move it a little bit to that side. Okay, so I'm going to try again. So in this case, it's the negative, it was correct, just get my color correct, 2 over 5. And it's going to be x, and I'm going to again do this. I'm going to say negative 2 over 5, and because the denominator is 5, I'm moving it still slightly a little bit, I'm going to subtract 5 over 5, just to help me, not to make unnecessary mistakes. Okay, so let's go for my finals here. So it's 1 over 2. Now, if this comes down, it's at the bottom x to the power of half, but I can put it back in the root. Okay. Remember, this is like this. So it's 7 times 7 is 49. over 3, and that is going to be x, and 7, but so this is going to, the answer is going to be 4 over 3. I will now put it back in the roots. And this is going to become a positive. Do you see negative times? So it's 2 over 5 and x, and this is going to be negative 7. Do you see negative? 7 over 5. And if I bring it down, it's going to be positive 7 over 5. Okay, but let's write a final nice step. Okay, so, and in this case, I'm going to leave it like this. I just want to put it back in roots. Remember how it works? The one on top is inside, and the one at the bottom is outside. Plus, and this is again 2 over 5, and now it moves down to get rid of that negative, and now I'm just going to get my root ready. So there is my x, and that is my tops, it's there, and that one is there, and that is my final step. Okay, it's very, very important to practice the rules before you start with the application. So make sure that you practice all the examples, and even some of the examples more than once, that the rules are really fixed and that you don't struggle with the rules when you come to the applications.